Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is binomial distribution. First of all, a little bit of stats here, but we will not go deep on stats tables, and so on. We go right through our Excel. So first of all, binomial distribution is based on a previous distribution called Bernoulli distribution. And Bernoulli distribution assumes that only two possible outcomes can happen: success or failure, or pass or fail policy in high ed, or I go to a store and I will purchase or not, or I have an accounts payable, I will pay it or not. So it's kind of yes and no. So I am a uh, telemarketing and I call my customers, they will purchase or not. So it is kind of yes or no. And each of these yes or no's with a constant probability of occurrence. And P is the probability of a success, and 1 minus P is the probability of a failure. So when we combine the yes or no's, it must be 1. It must be 100%. So there is no maybe here. And then can be used to model whether an individual responds positively or negatively, telemarketing promotion, and so on. And then the P will always be the probability of success. Just like here, P, probability of success, 1 minus P of failure. So, okay, now what is the binomial distribution? An independent replication of a Bernoulli experiment, each with a probability P of success. And X represents the number of successes in this N experiment. And then here a huge formula that we are not going through that, and we are not going through the stats table as well. That is 20th century. We are on 21st century, so we have better tools to do that. So here is the binomial distribution function on Excel. And then, what is the difference? This cumulative can be true or false. Cumulative, true. Cumulative probability. So, okay, I have 30 customers going to my store, and what is the probability that at least 10 purchase something? So at least means cumulative. Or what is the probability that exactly 10 customers will purchase it? So it is the false. So let's go to our Excel file and let me delete one and the other one, okay, because I will not be doing the math twice. So suppose that 20% of customers that go to Scarpin restaurant, my fake restaurant, on weekdays, that 40% of customers that go to the Scarpin restaurant on weekdays and 40% that goes on weekends spend more than $20. In a sample of 15 customers, and we can go here on 150, depends on the number of rows that we are adding to our Excel. And I only add 15 to have all of them in one screen. Show the probability of spending more than 20. So weekdays 0.2, weekend 0.4. So first, let's go on the false. That is exactly. So number of customers here. So let's call it customers. Oops. Customers. 0 customer. What is the percentage that no customer purchase more than $20? So we go on formula, insert function. Let's go on all. That is the easiest way for you to find it. Binomial distribution. Okay. What is number of S? So number of S is the individual term, so no customer. Trial The distribution probability, 0.2 or 20%. And then F4, we fix it. Probability. Oh, sorry. Trials is the number of customers. So trial is the number of customers. That is the individual term binomial distribution probability, and trial is the number of independent trials. So what is my sample size? 15. And now the probability S, 0.2. And then cumulative. So here, false. It is no cumulative. I have here that 3%, and here, guys, I am doing on percentage only because the visualization is better. If you go to stats textbook, it will show you on decimals. It will show you just like that. So, okay, there is a 3% of probability that no customers at all will be purchasing, and we copy and paste. The highest probability is here. Exactly 3 customers will purchase more than $20, 25%, 1 in 4. Okay, so, but here, there is also the cumulative. We can do on 2 ways. So here, just like any other cumulative, beginning balance plus blah, 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 and then we can go on that. Or we can go on the binomial distribution again. And if we go to most recently, it will be the first one. So number of S, number of success, 0. Trials, independent trials, 15. And let's fix it. Probability, 0.2. Fix it. And here is true. So the first number will be the same. There is no beginning balance. And then let's copy and paste, and we are here. So at least 3 customers, 64%. So 2 in 3. So more than 50% of chance. But this cumulative at least 3 means no customer, 1, 2, or 3 customers. And if we want to go to the cumulative probability on all of this range here, or from 4 to 7, go 7 minus 4, and then we are good on that. And then if we go to 0.4, 40% of probability on weekends, we have this cumulative, or this exactly number. So here we have, it goes to the right because the highest number is 6. That is good. 6 customers will be purchasing more than 20. Or the cumulative, only here, almost 40% of probability that at least 2. Here, only 2%. Oh, that is so bad, only 2. Yes, because 97.3 percent of chance that they will be spending less than 20. So the 18 remaining will be spending more. And here, if we go on 39, here's the 40. At least 2 will be spending $20. 40% here, at least 5 will be spending it. And then let's charge this one. So let's go here, or weekdays, weekends, and for the what we call here exactly. And let's merge it. And let's copy and paste. Here, not exactly, it is cumulative. And then let's work on it. So exactly on weekdays, 3. On weekends, 0.4. Cumulative, 3. Cumulative, 0.4. And let's go here. Now let's add some charts. So exactly, and check how the distribution works. So column, whoa, 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 whoa. So here, what can we see? See that the blue distribution is to the left. We say that it is negatively skewed. Here is a little bit negatively skewed because when our probability is exactly 0.5, then it is perfectly skewed or normal skewed or neutral skewed. You can name it on a lot of names. If it is 0.9, positively skewed because, wow, that is 99% or 98% of that. At least 6 customers will be purchasing or 99 and so on. So it goes very to the left. But let's go back to our original numbers. And then cumulative, we do the same chart here. And let's move myself to the top. Cumulative. Then this cumulative looks like a Pareto chart. So, okay, here is the cumulative. So for here, we have more on lowest numbers and here more on highest numbers. And that is good because we have here at least 11 will be purchased, much better than at least 7. Okay, so guys, this is the binomial distribution. Not that easy. So watch this video as many times you want. And here we have another one for Tableau because we have the same business stats, business analytics curve for Tableau. Go on our playlist. You will find it there. Okay, guys, so thank you so much. Have a very nice day. And by the way, questions or comments, leave it here or email me at jscarping@gmail.com. God bless you guys.